So this is part 2 to the video on sample spaces and tree diagrams. Last video is on sample spaces. Now we're going to be talking about tree diagrams. So what a tree diagram is it's a tool that allows us to find the number of possible outcomes of an event or an experiment and to generate the sample space for that particular experiment. Okay, so let's look at an example now. Okay, so here our example says a lunch special at a restaurant comes with 2 choices for soup. We'll call them S1 and S2. 3 choices for entrees, we'll call them 1, 2, and 3, and 2 choices for desserts that we'll call D1 and D2. Now they're asking us a few things. So first they're asking us how many ways can lunch be ordered. Then they're asking us if lunch is ordered at random, like one lunch is ordered at random, we want to find the probability that whoever is ordering lunch ends up choosing the first soup, the second entree, the first dessert, or the probability that they chose the first dessert and the third entree, and then the probability that they chose the second soup and the second dessert. In order to figure this out, we can draw a tree diagram to help us generate the sample space, and then we can find the probability that way. A tree diagram will also tell us, answer part A for us. It'll help us figure out how many ways we can order lunch. Then once we know that, it'll be a little bit easier to find the probabilities of these things, and the tree diagram will also, help us do stuff with this. Okay, so for this situation, first we're going to look at what happens when we start. So at the start, the first thing that we choose is a soup. So there's 2 possibilities here. The first choice we make is choosing the first soup or choosing the second soup. Okay. That's the first choice we end up making. You can only choose one of those 2 things. Now, since we've chosen a soup, we have a few more choices to make after that. So we now have 3 choices for entree. So we could choose to order the first soup and then order the first entree, the second entree, or the third one. Same possibilities go for if we started by choosing the second soup. Now that we've done that, we have to choose between the first dessert and the second dessert. So you could choose the first soup, the first entree, and then the first dessert, or you could choose the first soup, the first entree, and then the second dessert. And same goes for everything else over here. Okay, so this is a complete tree diagram for the scenario here. Okay, so now how does this help us solve the problem? Well, we wanted to see how many possible outcomes there were, or how many different ways we can order lunch. So if we follow each branch of this tree, this tells us a different possibility or a different thing in the sample space. So if we follow this first branch up here, this gives us one possible way of ordering lunch is the first soup, first entree, and first dessert. So that's one possibility. Now, if we were to follow, again, start at this branch, right, get the first soup, get the first entree, and then we could choose the second dessert instead. That's another possibility. And over here, now we could order the first soup, we could get the second entree, and we could get the first dessert. And we can follow along every other branch of the tree like this to get every other possible lunch that could be ordered. Okay, so this shows us every different lunch that we can possibly order. So let's go back to the question here. They wanted to ask us first, how many ways can lunch be ordered? So now we just need to count up all of these possibilities. Okay, so we'll start counting. We have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different ways. Right, so here, how many ways can lunch be ordered? That's 12. Now we'll go to part B of our problem. So here, now they're asking us something different. So they're saying if a lunch is ordered randomly, we now want to find the probability that, it'll contain any of these items here. So the first one is they want to find the probability that it'll have the first soup, second entree, first dessert. So if we go back here and we want to find out, well, how many of these possibilities feature S1, 2, and D1, this is the only possibility over here. Right, so we only have 1 out of the 12 possibilities that feature all 3 of these. So our probability over here is going to be 1 out of 12. Okay, and now let's look at finding the probability that a random lunch we order has the first dessert and the third entree. So now we want to look for any option here that has the first dessert and also has the third entree. So let's see, this is one, and then this is the other one. Okay, so here we now have 2 out of the 12 possibilities. So this is going to be 2 out of 12. Now the next thing they're asking us is that it contains S2 and D2. So again, we can go back to our chart over here and look for however many options have S2 and D2. Okay, so we have, this is one over here. This is one over here. Okay, S2 and D2 is over here. Okay, so we have 3 possibilities. So our probability over here is going to be 3 out of 12. Okay, so now I'm going to leave this question up. You might want to pause the video here and try to solve it yourself. You can solve it the same way as the last example. So in this question, we're, supposing that we're taking a 3-question true or false quiz. First, we're being asked how many ways can we randomly guess on the quiz. And then in part B, we're being asked to find the probability of guessing all questions correctly. I would say pause the video here, try and go through this question on your own, and then I'll walk you through the solution. If we're taking a true or false test, what that means is there's 2 possible answers for each question. Or 2 answer choices per question. Okay, so we have 2 answer choices for each question, and that's going to help us draw our tree diagram. When we start taking the test, right, there's our first question, and if we're guessing, we could either guess true on that question or we could guess false. Now, when we get to our second question, again, we could either guess true or false. Okay, and now when we get to our third question, again, we could guess true or false on each question. Okay, so these are all the possibilities for guessing on each question. Now, if we wanted to see what all the different possible ways we could guess are, again, we could follow each branch of the tree and see what that is. Or we could count up the ends, and that'll tell us how many possibilities there are. So here we could first guess, true, true, true on everything. Then over here, true, true, false, true, false, true, and so on. Okay, so these are all the ways that we could possibly guess on this test. Now, question A is asking us how many ways can we randomly guess? So we could go through, count up all of these possibilities. We see there's 8 different ways to guess. So there's 8 ways to guess. Now B is asking us to find the probability of guessing all questions correctly. So we don't know whether the answer to any particular question is true or false, but we know that out of these 8 possibilities, only one of them is going to be right if we assume that a true-false question, each of them only has one correct answer. So we don't know which way is the right way, but we know only one of these is going to be the correct one. If all the answers are true, that's the only one, that's correct. So our probability here would be 1 out of 8 for guessing correctly, because there's only one correct solution or only one way to guess correctly out of the 8 possible ways you could guess if you were guessing at random.